Graphing motion, part 2, transposing graphs. Well, transposing means to change one sort of graph into another. What do I mean for transposing graphs? Well, consider, here's an acceleration graph for dt. A dt graph that's a curve means acceleration. Well, here's a vt graph for acceleration. It's a diagonal line. So if I'm given just one, how do I know what the other is going to be? How can I change one to the next? How can I transpose one to the next? They're different graphs representing the same type of motion. Well, let's see. Here's another little memory aid, you might say. Notice what I've got here. I got 4 graphs. In a way, they're getting a little less complex. It goes from left to right. I go from curve to diagonal to a horizontal line to a zero horizontal line. I'll just call it a zero line there, okay? And I take my DVAs and I line them up here. I can line them up there. I'll start by lining them up here. Now why? Well, if I get the alignment like this, it means a DT graph that's a curve is the same as a VT graph that's a diagonal line, which is the same as an AT graph that is a horizontal line. Slide it over a bit. A DT graph, if you're given a DT graph that's a diagonal line, the VT graph that's equivalent to it will be a horizontal line. The AT will be a zero line, zero on the horizontal. Slide it over once more. If you're given a DT graph that's a horizontal line, the velocity line will be zero, the graph of the VT. What happens to A? Well, it's pushed off the edge. We won't worry about it. There's trends and patterns, and trends and patterns enable predictions. It's such a big part of science, right from the periodic table. Dmitri Mendeleev, he didn't know why these elements had the properties they had. He didn't know about electrons and such, but he was able to make predictions based on the patterns. And likewise, that's happening here. Again, you say this is related to a thing called calculus, a branch of mathematics. We won't worry about that. Let's try it with a couple questions. So here, identify the DT graph. That's down here. Best corresponds with the given VT graph. Oh, okay. Well, the first thing I'm going to do is write my 4 graphs down there. A curve to a diagonal to a horizontal to a zero. Then, well, V is what I'm starting with, so I put the V under the diagonal line because I'm given a diagonal line for the V. And now I can predict what a DT graph would look like and an AT graph would look like. But I'm just asked about the DT graph. Oh, it's going to be a curve. So the answer has to be letter D. It's the only curve there. Another example, identify the VT graph. So these are VT graphs down below here. It best corresponds with this DT graph. So once again, I write down my 4 graph shapes, curve to a diagonal, to a horizontal, to a zero. The D is a diagonal, so I take my DVA and I place the D underneath the diagonal. And the V and the A start lining up. The V would be a horizontal line. So I look through here. Oh, there's only one that's a horizontal line. That is B. B would be the answer. It matches. Let's do another example or two. Identify the DT graph. Okay, these are DT graphs that corresponds with the given VT graph here. Okay, so I have to transpose, change one sort of graph to another. Now this one's a bit more complicated because there's 2 sections to this graph. We'll have to do one section at a time. So I write down on exam, I would draw this by hand, of course. Curve to diagonal to horizontal to a zero. V is firstly a diagonal, so I would place V under the diagonal, and D and A just naturally slot themselves in under their shapes. So V is a diagonal, the D should be a curve. So I look through all my graphs. Well, that's not a curve. It's out of the running. That's not a curve. That's no good. C and D are curves. They're looking pretty good. Go to the second section on my VT graph. Go to the second section on my VT graph. It is a horizontal line. So I slide the DVA over. See, I can slide it over like this. The V is a horizontal line. I can now predict what a D graph would look like, a DT graph, or an AT graph. But I'm asked about the DT. It should be a diagonal line. So I look at C and D, and oh, that looks to be a horizontal line. That is not correct. It's got to be letter C. How about one more? I'm given a DT graph, and these are all VT. Which DT graph means the same thing as that DT graph? Okay, well, I have 2 sections there. I'll do one section at a time. So I write down my 4 different graph shapes: curve to diagonal to horizontal to 0. My D is firstly a horizontal line, so I put it under there, and the VA line up. A sort of falls off the end of the earth there, it doesn't matter. So if my D is a horizontal line, V must be a 0 line. Look through all those, that's 0. That is not 0, that's wrong. That's the diagonal line, that's wrong. D is looking good so far. Now, for the next section, here D is a diagonal line. So I slide things over, D is on the diagonal. V is under horizontal. So my VT graph must be a horizontal line. Well, definitely not that one. Yes, A is looking good. And notice in all this, I'm avoiding the 4th quadrant.